In chapter 5, we introduced something called the z-score. For a sample and a population. Remember what's the difference between z-score samples and populations in the formulas? Well, yeah, population is much greater, but I'll show you. In a sample, we use our alphabetic letters. In a population, we use the Greek letters. That's how you can tell which one you're looking at. What's that? A? This one? The X represents an individual data piece. The X bar and the mu represent the mean of the sample or population. And the S or the rho is the standard deviation of the sample or population, respectively. So up until now, we've learned how to find the mean and the standard deviation. And all depends on what kind of data set you're given. Whether it's a binomial distribution, whether it's a frequency distribution, whether it's a probability distribution, each one of these sections we covered have their own formula for the mean and standard deviation. So let me show you, because there's actually something between the mean and the deviation. It's called the standard variance. So basically, this is the direction we go when we start finding these things, and we'll discuss what they are looking for, what they prove in a second. So first, you start with your data set, or what we call the sample space. Remember, the sample space is all your data in as simplified form as it can get. Once we have our data set, the next thing we do, calculate the mean. What does mean mean? The average. But we never use the word average when we deal in statistics. We always use the word mean. So how do you find the average, the mean?
on your sample size divided by.
Add all your samples, your data set, and divide by how many you have. Where n is the number of data in your sample space. We call n a cardinality. A cardinality is simply a number, a solid number that depicts how many data sets do you have. All right, so we use start with our data set. These are the X's. Add up all the X's and divide by how many you have. That finds a mean. X bar is your mean. From there, we calculate the standard variance. What the standard variance is you look at how far are each of your data points away from your mean. So that symbol is S squared. So it's X minus X bar over N. You have to be cautious here because sometimes, depending on the type of data you have, you're either going to have N or N minus 1 in your denominator. All depends on the type of analysis you're doing. And if you don't do the N minus 1 when you're supposed to, then you'll come up with a it's going to be very close to the other answer, but it's still going to be wrong. And that's it. And depending on the type of data you have, whether it's binomial, whether it's probability, whether it's frequency. Yeah. So again, each one of those sections, they have that formula in that section. Again, what I advise you all to do is, as we go through each chapter, write down all the formulas that are in there and a little, in your own words, what they mean, what they're for. Here's a cool thing about it. If you add up all these data points and you add them together, what should you equal? The absolute values. Yeah, that again, that's another one. We have another one which uses square rooting or squaring. Now, the reason for this is because the standard variation, here's your mean. In order to be the mean, what has to be true? You have to have some data points that are less than it, and you have to have some data that are greater than it. So the distance of all of these and the distance of all of these should be equal if that's your mean. Because remember, it's the middle of the road. So if I took this one minus that, these are all going to be negative answers. These are going to be positive, and when I add them together, they should cancel out. That's a test you do to make sure you have a correct standard formula set for your standard deviation. If the sum of all these variances does not equal 0, then something's wrong. Go back and look at your numbers. Probably your mean is wrong, or you're missing some data set. That's 1, 2, this is 3. This is step 4. Calculate the standard deviation. Now, the problem with all these variances is because if I just do this, I'm going to get a negative answer and a positive answer. So how do we get rid of the negative answers? We square them. So the calculation for standard deviation, the symbol we use is just S. And take each of our variances and square them. Depending on which one you use. Because what we've done now is we've gotten rid of all the negative numbers. We made them all positive. So they won't be 0 anymore. But what's going to happen is because I squared these, they're going to be super large. So what I have to do is I have to shrink a square by taking the square root of it. Yeah, here. Because if we add up all these S's this way, we get 0. That's the reason we square here. Because we're gonna get some awfully huge number. So the standard deviation is simply the square root of the standard variance. Because in chapter 5 and beyond, we'll mostly use the mean and the standard deviation in our distribution charts. The bell curve. Whenever we want to refer to the bell curve, we say something is normally distributed. The middle of your bell curve is your mean. So that's the X bar. How does the standard deviation come into play? Well, on both sides, we have 3 standard deviations. On the right-hand side, we add the standard deviations to the mean. On the left-hand side, we subtract the standard deviations from the mean. So far, so good? within the first standard deviation, we're gonna have approximately 65% of our data. Within two standard deviations from our mean, we're gonna have approximately 95% of your data. And within three standard deviations, we're gonna have 99.7%. So with that, with what we have so far on this chart, normally distributed chart, what amounts are in both of these tails, these ends? We know that the third standard deviation is 99.7. So what's left over is how much? 0.3. So if 0.3 is left over and there's two sides that's divided by 2, we get 0.15. So this side is 15%. And this side is, no, 1.5%. So those are the very, very, very outliers, which is why when people grade on a curve, only the smallest percent of people make the A's, then B's, then C's, then D's. Anybody below the mean, fail. So this would be the A's, this would be the B's, this would be the C, D, and everybody out here is F. Yeah, so you see how not fair it is for us who are down here. So that's an average normal standard deviation. But we have other types of deviations. What if we have a uniform standard deviation? When we have a uniform standard deviation, we don't use a bell curve. We use a rectangle. And this one goes back to the days of algebra. What formula can you tell me about a rectangle? We can figure out the perimeter, the outside of it. How about the inside? What's that called? The area. What's the formula for area of a rectangle? But for our uniform standard deviation, our area is always 1.0. It's 1. So your horizontal axis is how many, let's say how many people you're observing or how many time intervals there are. It's always to do with some sort of interval. So whether it's quarterly, monthly, weekly, hourly, minutely, whatever, that's always on your horizontal axis. On the vertical axis, that's what we have to calculate. For example, let's say that our span was from 0 to 7. Let's make it easier. Let's make it 5. So this is our width. What's the length of the width? How do you figure that out? Well, 5, take the biggest number minus smallest, we have 5. So the width equals 5. Take the second number minus first number, and that tells you how wide it is. Now what we have to do is figure out the length. We know that the formula for area is length times width. We have 2 of these variables defined. What's the area? What's the area? 1. The width is 5. Calculate L. So divide both sides by 5. So the length is 1/5, which is 0.2. Again, look at the answers, make sure you know how many decimal places they want you to have it. Because if you don't put enough decimal places, then you won't get our answer. Is that what you did? So we know our length is 0.20. Okay, so that gives us, and we can always test it. 5 times 0.2 is 1.0. Now, what's the question is going to ask you is, so this is, let's say this is 5 people go through the door every hour at an art museum every day. 5 people go see an art museum every day. What if we want to look at the probability that the number of people is greater than 2? Or it should be greater than or equal to 2. So with that, if we look at the graph of it, here's 2. So we're looking for is the area of that part of the curve, because it's greater than 2. Because now we're making the transition where area under a curve equals the probability of an event occurring. We're now making that big jump. Yes. Yes. So we're looking for the area. What's the area under this curve? It's length times width. Here's width. Here's length. Well, the length itself is always going to be 0.20. In our case, what's our width? Yeah, it's going to be the last number minus the number we're starting off at. 0.20 times 3 is 0.6, or 60%. There's a 60% chance that more than 2 people are going to walk through that door in the next day. So that whenever you have a uniform distribution, that's what you look at. You use that rectangle. Pretty much everything else we're going to look at will follow this. Well, let's make it mu. When we look at the population, the mean will be equal to 0. That's the center. Why do we have to have it in the center? Because anything to the left of it will be negative. Anything to the right of it will be positive. And the standard deviations on standard is going to be 1. So that's what makes it much easier for us to calculate. So this is 0. That means this is 1 standard deviation, 2 standard deviations, and 3 standard deviations. This is -1 standard deviation, -2, and -3. The charts we're going to look at are either negative or positive z-scores. And this is this is for our standard normal distribution. And what's our z-score formula? X minus X bar over S, or X minus mu over rho. So far, so good? Because we have to be given, or we can calculate the mean, the standard deviation, and we have to give a value that we're looking at. Once we convert this to a z value, in 2 decimal places. Why do we want 2 decimal places? Because that's what our chart is defined as. We have 2 charts we're going to be looking at. One is for negative z-scores, and the other one is for positive z-scores. And this is what they're going to look like. If your z-score turns out to be negative, what does that tell you? Where on this horizontal axis is your data point you're looking at? To the left or to the right of 0? Yeah, if it's negative, it's to the left. It'll be a negative value. If it's a positive z-score, it's going to be on the right. So far, so good. Now, the way you use this chart is from that z-score, we look at everything to the left. That's the answer to that z-score problem. It's kind of like when we did the percentiles and the quartiles. This number is bigger than how many other numbers? So that's what we're looking at here.
Either one, it doesn't matter.
It always goes to the left, right? Correct. Left, right. Correct. Because what you're going to see in your chart, let's just say that for the first one, our z value was negative 1.03. And let's do for this positive one, let's do the positive 1.03. Just by looking at these two graphs, can you come up with a hypothesis of what those values should look like? Or what the areas should look like? Yeah, the shaded region is what we're looking at. This is our probability. This is our probability. Well, let's look at this. So since the first one's negative, it's to the left of the mean. We'll use this chart. Remember, it's negative 1.03. We'll use this chart, the negative z-scores. It even gives you a picture to refer. If you're doing to the left, and it's on the left-hand side of 0, we use this chart. Here's your z. On the left column is one number to the left of the decimal and one number to the right. The second decimal point is up here. So our number was negative 1.03. So on this column, we go to negative 1.0, which is here. And then go over to 0.03. That's 0, 0, 0, 1, 0, 2, 0, 3. Because that one there is at 0.03. So that's 1.03. The answer is 0.1515. .1515, which tells us what? How many percent is that? 15.15%. So in reality, what that means is if this is a test and you scored a number X that gives you a z-score of negative 1.03, that means you're only bigger than 15, you're only higher than 15% of the class. So now let's look at this one. This is a positive z-score. So we go to the positive z-score chart. Again, it's showing us that the shaded region starts off to the right of the mean. And we do the same thing there. 1.0, go all the way to 3, and you get 0.8485. So for this one, the answer is 0.8485, or that means 84.85% of the data points are below it. So far, so good. So let's say the mean was 20. You're looking for a value of 15. and the standard deviation was 2.5. Tell me the probability, the percent chance of that happening. So first, you have to find the Z value. So it's X minus the mu over S. So it's 15 minus 20 over 2.5. Fifteen minus 20 is -5 over 2.5. So the answer is going to be negative. 2.5 goes into 5 how many times? 2 times. So that's our Z number. Let's first go. So remember, our mean was 20. Our standard deviation is 2.5. So how do these two relate to each other? If I start with 20, that's my mean, and I add 2.5, I get 22.5. I add 2.5 more, I get 25. And then 2.5 more, I get 27.5. So these are the values at each of these standard deviations. Now to the left, I subtract it. So 20 minus 2.5 is 17.5. 17.5 minus 2.5 is 15. 15 minus 2.5 is 12.5. So our X landed right here. And the number we're going to look at is everything to the left of that. So which one do we use? Top or bottom? Bottom was having negative, and we look for what number? Negative 2.00. So that is 0.0228. So the 0.0228, which means the probability is 2.28%, or it's larger than 2.28 of the data. Straightforward. Now, the question you should ask is, okay, I thought you said mean was supposed to be 0. Well, let's look at this. These are our actual data points. This is referring back to the data. This is the data. Now, our Z values. Let's find this value here. So when X is 20 minus the mean, which is 20 over 2.5 is 0. So that one is 0. And this one here is 22.5 minus the mean over 2.5. So it's 2.5 over 2.5, which is 1. Remember, our chart said here, our standard deviations are 1. So that's 1, 2, 3. That's after we convert it to z-scores. So if you're using our data numbers, our data set, yes, you'll have these. If you convert this to z-scores, you'll have 0, 1, 2, 3, 0, 1, 2, 3. And our value fell right here, which is exactly at -2. Told you it wasn't hard. Is it hard? Not yet.
It's just,
No, if I'm losing you, tell me.
no, this makes sense. It's just, I'm like thinking about what all came before it. but
Well, see, and the thing about it is not much really matters, but I cut you off. Everything you need to know earlier. Yeah, and we'll get caught up here. After tomorrow's class, we're going to try to finish chapter 7 tomorrow. Is on Wednesday, Thursday, Friday, I will be here to answer whatever questions of the chapters we missed. All right. So I don't want you guys to be threatened about that. And I'm extending the deadline to Sunday at 10 o'clock or 11 o'clock at night. I'll make it Sunday, 11:59. I mean, yeah, because I don't have to go to sleep. So as long as I get the grades in by near midnight, I have, at least I'm starting by it, so it won't kick me out.
Do we have to submit grade info?
That's what I have to check. I think typically they're Monday by 9. Well, my part, I submit them as soon as I get them. I put them in my spreadsheet, calculate it out, and I will post it before I go to bed on Monday morning. So before you wake up Monday, it'll be on eCampus. Not eConnect, eCampus. So everybody gets that confused. I looked at our Blackboard and I don't see the grade anywhere. No, the grades will only come from eConnect. And be very careful also, because on your assignment sheet, you have all the other stuff, all the videos, all those other stuff. Those will give you extra points, hundreds in here and here. Those, I delete all those. I only take the homeworks and the tests. All the other grades get deleted. So beware. Okay, now what if I gave you this? The mean was 50. Standard deviation was 10. And I want to know the area between, or the probabilities between, let's say, 25 and 70. Let's go ahead and draw out what we have here so we have a better look. So our mean is 50. Standard deviation is 10. So everywhere to the right, I add 10 to the mean. So 50 plus 10 is 60. That's my one standard deviation. 60 plus 10 is 70. That's 2 standard deviations. 70 plus 10 is 80. That's 3 standard deviations. Because at each step, I add 10 more, because that's standard deviation. Going to the left, I subtract 10. So 50 minus 10 is 40. That's -1 standard deviation. 40 minus 10 is 30. That's -2 standard deviations. And 20 is our -3 standard deviation. But one you can look at it is this. If I had -3s, s is 10, so -3 times 10 is 30. -30 plus 50 is 20. So that's what it tells us. All right, so that I just set it up. Now I'm looking for this. I want to go from 25 to 70. I want all of the area between these two. But remember, the charts deal with everything to the left of the number. How do I find this one? Because I don't want this left tail here. I don't want that. How do I get rid of that? You pulled a Houdini. I looked up, you were gone. So this looks in two pieces of two different pictures. So here's the mean. So the bottom one here, the left one. The chart will find me that area, right? I don't want that area. The other one will give me this one. Give me this whole area. So how do I find the area between 25 and 70?
First area, right? So you get that.
Right.
And then you get that one. So then you get that to the-
Yeah, so this is P1, this is P2. So our probability becomes P1 minus P2. Very good. So what's the first thing we have to do? Remember, our mean is 50. Standard deviation is 10. And our x's are between 25 and 70. What do we need to use the charts? Let me give you a hint. We need the z-scores. Because remember what the charts are titled? Negative z-scores, positive z-scores. So we have to know the z-scores.
So put a negative 25 and then
Nope. Just use them as they are. So let's look at P2 here and do P1 here. So the z value is x bar minus x minus x bar over s. And it's x2 minus x bar over s. This is x1 and x2. So this is x1 and this is x2.
I guess I'm confused because the 25 appears to be positive, but we're using it as a negative. on-
But yes, well, let's put it in here. Let's see what happens. Remember, this number here, where is it situated with respect to the mean? The mean is what? 50. Where is 25 with respect to the mean?
Well, it's lower.
It's to the left. And that's what it tells us. It's not assumption, it's a fact, but that's what it's supposed to be. It tells us if we get a negative z values, that means that number is to the left of the mean. Because of how it's written out. We got 25 minus 50 over 10. So it's negative 25 over 10, which makes it negative 2.50. This tells me that my 25 is to the left of the mean. remember, it's not an assumption, it tells us exactly where it's situated. And likewise, the 70 is just 70 minus our mean over 10. 70 minus 50 is 20 over 10 is 2.00. So that's 0, and this is negative 2.50. We're going to find this area here on the chart. Then this area here will be at 2.00. It's going to find this whole area. Yeah, so as I see what your question is, it's a very good question. Where's the negative? It just tells us relative to the mean, where are our values? Negative means to the left, positive means to the right of the mean, and that's exactly what it tells us. So the first one is negative 2.50. Let's look at our chart. 0.0 is our far left column, so we go to negative 2.5, which is 0.0062. That's 250. 0.0062. 0.0062. And this one is a positive at 2.0. So we go to 2.0 is 0.9772. So this is 0.9772. Subtract the 2. 0.0062. And the final percentage is 97.10. Okay, that's looking everything to the left. Let's look at things to the right now. We use the same information. 50, standard deviation is 10. I want all the x's greater than 30. So let's draw a picture with our data points. So there's our mean, which is 50. The standard deviations are 60, 70, 80, and left side's 40, 30, 20. I want all the x's greater than 30. So I want this one to that direction. There is. Yeah. What's the other way? Because it is exactly on 2 standard deviations. You could do that. Well, let's check it out. We'll check it out. So this is -2 standard deviations to the left. We'll see what happens. And then we'll see what you did. We'll check at 70 and see if it's giving us the same answer. All right, so first convert it to z-score, which is x minus x bar over s, which is 30 minus 50 over 10. Negative 20 over 10 is negative 2.00. Our chart at negative 2.00, negative 2.00 is 0.0228. And that finds this area, 0.0228. So to find, this is what we don't want. This is what we want. How do we figure out this area? Yeah, so the whole thing equals 1 minus 0.0228. And that'll give us this probability. So it's 1 minus 0.0228. Zero point 9772. So it worked actually. So if you're looking for a number greater than 30, greater than or equal to 30, you have a 97.72% chance of getting that number. And 2.0 positive is 9772. So perfect. Yeah. Yeah, you're right, because it's exactly on those lines. I never thought about that, but you're actually correct there. Good thinking. So yeah, if you only have one chart, you can use that by flipping the numbers around.
Something that's
Very good.
never did you.
Make him, yeah, I said the same thing also many years ago. It's because I hated negatives. Very good though, very good. How about this one? I'm gonna use the same numbers. But this time I want X to be less than or equal to 15. Let's make it 35. Or X is greater than equal to 55. Yeah, so first we have to do is find the z-score. This is for X is less than equal to 35. Or X is greater than equal to 55. Because if we draw a picture, it'll give us a better idea of what we're looking for. Here's our mean, which is 50. We want less than 35. So that's this area. Or we want greater than 55. That's this area. We want the sum of those two areas. And you're right, you can use a negative chart for both of these. So Z1 is
Negative 2 and Which 30?
35. Yeah.
Oh, it's 30.
35 minus 50 is negative 15 over 10, which is negative 1.50. That's my first z-score. And the second z-score is 55 minus my mean over my standard deviation. 5 over 10 equals 0.50. This one is straightforward. So we look at negative 1.50. Negative 1.50 is 0.0668. 1.50 is 0.0668. You want me to leave it longer and can you get enough time to view it? I really don't mind, I'm sorry.
Figure it out, but then
Okay, now, since this one is greater than, we could find this, the area we don't want, subtract it from 1. Or, since this is the area, we just look at the negative side and look from that side. So let's look at, so this case, it'd be, instead of be 5, 5, so it's 4, 5. Which gives us 0.50. 0.50 is 0.3085. Ooh, that's horrible. 0.30, yeah, it's 0.3085. Since they're going different directions, I add the two z-scores. 0.0668 plus 0.3085. So it's 0.03753. Make sense? Okay, that's going from value points to finding areas under a curve. Let's go backwards. What if I give you the area? I want to know what value corresponds to that area. The probability of some value x is equal to, let me pick one here, 0.0060. And the mean was 50 and the standard deviation was 10. What x value is that percent? So we have to work backwards. But literally, we have to think backwards. In the other way, when I give you all the numbers, you found the probability. What was the last thing we did? We used the chart. So I'm saying I have 0.0063. So we take the chart and we look everywhere for 0.0063. And we notice that it's slightly increasing if we look at it. So We keep on looking at these numbers till we find 0.006, or no, some number the closest to it. Which is 60. 00, there it is, 0.060. So what z-score does that correspond to? Negative 2.51. So step one, find that decimal value on the chart. How do we know that this number here was on the negative chart? Yeah. The negatives go pretty much from 0.0000 all the way to 5.0. That's the negative chart. The positive chart, since it has more area to cover, it starts off at 5 and goes all the way up to 0.9999999. So if you have a very large number, because the thing about this number here has this area plus 0.5. So it's automatically going to be bigger than 0.5 automatically. So since this is a small number, we know we have a negative value. It's going to be to the left of the mean. And record the corresponding z value or z-score. So for our chart, we had 0.0060. It was at negative 2.5 and 0.01. Right. So the z value is negative 2.51. Check. Now, once we found the z value, work the z-score formula backwards. And solve for x. Well, we'll get there. So we have the formula here. Plug in what we know. We know x bar is 50, s is 10. And our z value is negative 2.51. Now we got to solve for x. Since it has a denominator, we have to get rid of it. Multiply both sides by the denominator. So in this case, the number is 10. So multiply both sides of the equation by 10. This 10 and this 10 cancel. So we have 10 times negative 2.51 is negative 25.1 equals x minus 50. add the X bar to both sides. In other words, we're gonna add 50 to both sides. So add 50 here. Add 50 here. With that, on the right-hand side, it gets our X by itself. So 50 minus 25.1 is 24.9. You can't escape algebra. It's always going to be the crux of our math existence.
She must have started out. And she was in first grade.
You did?
But when-
Oh.
What?
Actually, you'd be surprised. What's worse is when they have these new math techniques that they have to use this particular method. No. If it works for you, it works for you, use it. Don't try to learn it my way. Don't, it's whatever you works best for you.
I was looking at her homework and it said that X.
It's confusing to me even. Let's see what else could we do in this section.
So the T-squared always is, there's no new charge for.
No. There are. Yes, you can find charts that have between this, some of them that have greater than, but typically you'll see these positive and negative charts. And it's always going to the left because that's exactly what the Z-score does, is finds a number to the left. And other people may find these charts that did the work for you. They just make sure. So these are the ones you'll be using. All right, let's go ahead and stop there so it gives you a chance to catch up. And we'll finish up everything tomorrow because we only have 2 sections in chapter 7 and we have one more section in this one really to talk about. And it's going to go pretty quick. Because chapter 8 deals with hypothesis testing. And what that means is we'll get to this. Chapter 7, these are the Z-scores. We have Z charts and we have T charts that we have to look at. That's the next chapter. Again, all of them, it all depends on the data set you have, how large it is. Tells you which one to use, the Z or the T. From here on out, pretty much it's all we deal with are charts. And remember, I will be here online on Wednesday, Thursday, and Friday. Make sure everybody, if you have any questions, either log on or show up, and we'll just do nothing but go over all the questions you have. All right, so everybody, good luck, and I will see you tomorrow. And please, please, please do the work.